Unit 2, Lesson 5, Twin Powers. In the Jump Start, we gave examples of each of the rules of exponents, and also by writing them the long way, we're able to prove that they actually work. So here they are. If you need them, pause the video. Otherwise, we're going to move forward. So here's some interesting rules of exponents that we're going to illustrate again through the lesson. You take a number to the 0 power and you're going to get 1 other than 0 itself. So first I did it by the exponent rules, then I did it by expanding. Same thing for negative exponents. First I used the rule, and then I expanded and canceled. So in this lesson, we're going to relate some key features of exponential functions. A lot of the graphing has been done for us already. So let's get into it. We have a dialogue between two students, Carlos and Clarita, and they're working on their math together. Carlos says, I've been looking at the graph of f of x equals 2 to the x on my calculator, trying to make sense of the graph when the inputs are negative. Here's what I see on my graph. So you see the graph to the right there. Observations that we can make is that the y values are getting smaller as you go to the left. Now, Clarita says sometimes it helps to make a table and look for patterns. I'm going to try that. So here's the table and here's the pattern. You can find the pattern. It is geometric by taking a number and dividing by the one that came before. So 8 divided by 16, 4 divided by 8, 2 divided by 4, they all equal 1/2. So as we go to the right, we can fill in the missing boxes by just multiplying by 1/2 as we go. Carlos now says, so here's what I think is really strange. Look at the graph of g of x equals 1/2 to the x. And so here, you can compare the graph with the previous graph. Okay, that's the one up here with the one down here. They are both curved, very similar. They look like they're related. They look like they're from the same family. The difference is one is rising to the right and one is rising to the left. So Clarita thinks, I think we should make a table to compare the two functions. I've added a row to her previous table. A row goes side to side, a column goes up and down. So what you notice is that when you looked at the graphs, that the graphs are mirror reflections of each other. And so to get this, well, all you have to do is to take the negatives and flip them over to the positives and vice versa. So for example, let me get a marker out here. 1/2 on -1 is 1/2 on +1. 1/4 on -2 is 1/4 on +2, and so on and so on. The similarities, they are reflections across 0, 1. They're basically the same shape, but mirror reflections of each other. And the explanation is that 2 and 1/2 are related numbers. They are reciprocals of each other. So then Carlos says, I remember this about negative exponents, that a to the negative n is 1 over a to the n. Negative exponents always have a twin, an equivalent expression that is written with a positive exponent. So in explaining what Carlos remembers about negative exponents relates to the relationships we've observed, it's that 1/2, if you put a negative exponent on it, is 2 to the -1. So really he's looking at 2 to the negative x along with 2 to the positive x. Clarita now says, I think we could play around with these negative exponents and use them with the bases other than 2. So, for example, we did this in two different ways. We showed on the left side, if you use the rules of exponents, how it works. But on the right side, I just expanded the numbers. So 32 is literally 2 to the 5th. And then 2 to the negative 3, well, that's 1/8. And you see it does equal the same answer either way you do it, whether by expanding, looking at the number in a calculator, or not. We did the same thing for number 7. And also, on this problem in class, I showed that you can actually use your calculator to come up with the number. We didn't have time for number 8, but Carlos now says, all of this work with negative exponents has made me realize something. I can write two different exponential rules for the same function. So the one on the left is 1/2 to the x, and actually there's a little mistake there. It should have a parentheses around it. So 1/2 to the x, but that's the same thing as saying 2 to the negative x. And similarly, for number 10, that's f of x equals 2 to the x. We could write it as 1/2 to the negative x. So if you do a reciprocal, the exponent changes to the opposite. And that's the key today. So Clarita says, wow, that's interesting. How can I tell if an exponential function is always increasing or always decreasing before I graph it? Well, if the equation looks like this, then if the b is greater than 1, it's growing. And if the b is between 0 and 1, it's shrinking. We'll emphasize that when we look at the takeaways on this. And it might be helpful to also play around with this a little bit on Desmos. Well, that's it for now. We'll see you later.